Hello, ladies and gentlemen. Today we're going to look at some more proofs with proven triangles congruent. And let's start with number one here, which says given segment AD is parallel to segment BC, and segment AD is congruent to segment CB, prove that triangle AED is congruent to triangle BEC. Okay, well, I'm going to first make my column. All right, and title my statements on the left, and their corresponding reasons on the right. All right, and my first statement, of course, is going to be my given information, which is that segment AD is parallel to segment BC, and that segment AD is congruent to segment CB. Okay, all right. And of course, that's all given to me. All right. I'm going to go marks. It's already marked, excuse me. Segment AD parallel to segment BC, and that they're congruent. Well, what I'm going to do is I'm going to highlight triangle AED, all right, which is that triangle right there. All right, and I'm also going to highlight the triangle I'm trying to prove that it's congruent to in a different color, triangle CEB. Okay, well, right now, I currently have one pair of parts marked congruent. I need more, all right? So I'm going to use the parallel lines first, okay? So, and by the way, there's more than one way to do this, but I want you to know that I'm going to do it with the parallel lines. If I run this transversal across those parallel lines, that's going to give me angle ADE congruent to angle EBC, all right? And I'm going to make that statement. I'm going to say, okay, angle ADE is congruent to angle EBC. And the reason I'm allowed to make that is called the alternate interior angles theorem, okay? All right. And now, if I run the other transversal, line AC across points A and C, all right, I also get another pair of congruent angles that are alternate interior angles. That's angle DAE. I'm going to mark that one with 3. Angle DAE is congruent to angle ECB or BC. Either way, BCE, it doesn't really matter, okay? All right, so, and I'm going to put 3 tick marks on that angle. Those two are congruent, and it's for the same reason, the alternate interior angles theorem. All right, and now that I've got 3 pairs of parts from this triangle on the left, congruent to 3 pairs of parts in the triangle on the right, I want to know how many of them are sides. Well, there's only one pair of sides. That's this pair right here. And where is that side over in the triangle on the left? Well, it's between these. So that one's set up for angle, side, angle. Is the other one angle, side, angle? And the answer is yes, angle, side, angle. Okay, so I can then say that triangle AED is congruent to triangle C. C definitely corresponds with A. They each have 3 tick marks on it. CEB, and my reason would be the angle, side, angle, triangle congruence theorem. Okay, all right, so there's number 1. Let's go down and look at number 2. In number 2, you're given that segment EG is parallel to segment DF. You're also given that segment EG is congruent to segment DF. And you're asked to prove that line segment ED, all right, is parallel to line segment GF. Okay, well, what we could do would be to prove some triangles are congruent and then get some corresponding parts of those and then do a converse of one of our parallel lines theorems, okay? So that's what I'm going to do. I'm going to start with my statements on the left and their corresponding reasons on the right. Okay. Our first statement should be that segment EG is parallel to segment DF, it's marked already, and that they are also congruent. Segment EG is congruent to segment DF, all right, and all of that's given. All right, now, what I want to do is I'm going to go ahead and prove that this triangle right here, triangle GED, is congruent to that triangle down below. All right, this triangle, triangle DFG. All right, I'm going to prove those two triangles are congruent. All right, by first saying, okay, all right, if I have these two parallel lines cut by that transversal, then I get angle EGD congruent to angle FDG. All right, so I'm going to make that statement. So my second statement could be angle EGD, angle EDG is congruent to angle FDG. All right, and my reason for being allowed to make that statement would be the alternate interior angles theorem. Okay. I also see that I have a common side from those two triangles. I'm going to put 3 tick marks on that common side and say that segment GD is congruent to itself, all right? And the reason I'm allowed to make that statement is what's called the reflexive property of congruence. All right. Every figure is congruent to itself. Okay, so that's my third statement. Now, I've got 3 pairs of parts from the upper triangle congruent to 3 pairs of parts in the lower triangle, okay? How many of them are sides? Well, I've got these 2 sides in this triangle congruent to those 2 sides, so I got 2 pairs of sides, and it's either hypotenuse leg or side angle side. Where is this angle? Is it formed by these 2 sides? The answer is yes. Where is that angle? Is it formed by these 2 sides with congruent markings on it? And the answer is yes. So I can immediately say that my reason is side angle side. And now I can say that triangle, and I'm going to name that green one, triangle GED is congruent to triangle. Well, G has 2 tick marks on it. Over there, the angle has 2 tick marks on it, is D. We went to E, which is going to correspond with F, and of course, G corresponds with D. All right? So now I know that I can then say that angle FGD, okay, all right, I'm going to make that statement. I can say that angle FDG is congruent to angle, so FGD, I'm going to put 4 tick marks on that one. 1, 2, 3, 4 is congruent to this angle up here. 1, 2, 3, 4, angle EDG, angle EDG. And the reason I can make that statement is corresponding parts of congruent triangles are congruent. Or if you want to use the definition of congruent triangles, you can. That's in essence what it is. Definition of congruent triangles or corresponding parts of congruent triangles are congruent. All right, congruent triangles. I would take either one of those as a valid reason. I prefer the CPCTC, but if I don't get that, that's okay. All right, and now my last statement will be what I'm trying to prove, which is that segment ED is parallel to segment GF. All right, so my next statement is what I'm proving. Segment ED is parallel to segment GF, and the reason would be the converse of the alternate interior angles theorem. Which states, if 2 lines are cut by a transversal such that a pair of alternate interior angles are congruent, then those lines are parallel. Okay. All right, let's turn the page and look at our third and final proof for the day. All right, our third and final proof says, given segment AC is congruent to segment AD, and segment CB is congruent to segment DB, prove that segment AB bisects angle CAD. Okay, well, I'm going to start with my statements on the left and their corresponding reasons on the right. And my first statement is going to be the things that I'm given, the statements that I'm given, okay, which were segment AC. Can you see that? No, you can't, sorry. Okay, segment AC is congruent to segment AD, and segment CB is congruent to segment DB. All right, and of course, that's all given information. So it's given. All right, now I'm going to go down and I'm going to look at what I'm trying to prove. I'm trying to prove that segment AB bisects angle CAD. Well, if I was going to need to show that, I would need to show that angle DAB was congruent to angle CAB. All right, because then segment AB would bisect angle or angle CAD. Same difference as DAC. All right, well, I can see that there's two triangles that might be congruent. All right, I'm looking at triangle ABC, that upper triangle right there, and it looks like to me that that triangle could be congruent to that lower triangle, triangle ABD. Well, when I look at those, I've already got two pairs of parts marked congruent from those two. So I'm going to find another pair. Well, I happen to see that they have a common side, that being segment AB. So I'm going to make that my next statement. So my second statement would be that segment AB is congruent to itself. It's a common side, and that is called the reflexive property of congruence. Every figure is congruent to itself. All right, now that I know that, I've got three pairs of parts from the upper triangle congruent to three pairs of parts in the lower triangle. That means that I need to figure out what it is, see if I can determine that those two triangles are congruent. And when I look, it's all three pairs of sides of one triangle congruent to all three sides of one triangle congruent to corresponding sides in another triangle. So those two triangles are congruent by side, side, side. So that's the reason, and I'd write that first. Side, side, side tells me that triangle, and I'm going to name that upper one, ABC, is congruent to triangle. Well, what corresponds with A? Well, that's A. What corresponds with B? That's B. And what corresponds with C? That's D. Okay. And now that I know that, my next step would be to say angle, I can do angle D, if I start at the bottom, DAB. I can say angle DAB is congruent to DAB, first, second, CAB. All right, and the reason we can say that is that those are corresponding parts of these two congruent triangles here, CPCTC or definition of congruent triangles, whichever one makes you feel better about it. Okay, all right, now that I know that, I'm going to mark them, 1, 2, 3, 4, 1, 2, 3, 4. Well, if those two angles are congruent, I can then say that segment BA or AB bisects angle CAD, and it would be by the definition of angle bisector. So my next statement would be that segment AB bisects angle CAD, and my reason I'm allowed to make that statement is the definition of angle bisector. All right, and we're finished with that proof. All right, if you have questions about any of your proofs, I want you to give me a call, I want you to email me, or you could show up in one of our Google Meets. Good luck, have a good day, thank you, bye.